V, I guess so. Correct. Current, how much current it is drawing? Nothing but I is equals to P by V, and then resistance is V square by P. From that we have done some problems also which is having higher rating of the power that will have less resistance. So that is what we got by we have just compared that resistances and all, and also we have calculated what here electrical energy also. Household electrical energy. 1 unit is equals to how much? 1 unit is equals to what is that? 1 kilowatt hour. So the energy, total energy consumed E is equals to what we said? Summation of WH divided by how much? 1000 in terms of kilowatt hour. This kilowatt hour nothing but unit. So if 1 unit is costing as X rupees, then total energy cost, total electricity bill will be how much here? E into X rupees. That is the cost of the electricity bill. That is what we have discussed about the what electrical energy consumed by the household appliances. And after that we have seen some more thing, that is what is that we have, whenever we have connected the two unknown values, nothing but unknown values means already different rated powers in series and then in parallel. Have we discussed that? Series parallel. Have we discussed that? No, right? I did not start it, I think. What we have done? Yeah, relations. Whenever the resistance is changing from R to NR, then what happens to the power? Whenever all the resistors are connected in series, at that time what happens? All the resistors are connected in the parallel, then what is the ratio of the powers and all. And also we have seen one more thing, applied voltage and then rated voltage also. What is the relation we got? Power consumed is equals to applied voltage by rated power whole square into the wattage, whatever they have given the specified power. What we got? P dash is equals to consumed power is equals to, what is the formula we got? VA by VS whole square into PS. That is what we got. This is also one of the important relation. And after that we will see the series and then parallel combinations first. So in series combination, here very important concept will be there. In series combination, which bulb will glow brighter? In parallel, which bulb will glow brighter? Whenever both are connected in the both the combinations, at that time what happens? This is the main concept in this. After that, effective power, however, we will get effective power formula is easy only. In the case of series, we will take same like the capacitor only. In capacitor, CS is equals to what is the formula? Effective capacitance is equals to what we can write? C1 C2 by C1 plus C2. In the same way, series power also equals to P1 P2 by P1 plus P2. Parallel nothing but we will just get P1 plus P2. So that will be easy only. Before that, you have to understand that which will glow with more brightness. In series combination and then in parallel combination, both will be completely opposite to each other. In series combination, the bulb with less wattage will give more brightness. More brightness is nothing but it is consuming more power. Consuming more power, otherwise power dissipated, power radiated, otherwise brightness, everything is same only. Bulb with less wattage, wattage nothing but what? Specified power. The bulb with less wattage gives you more brightness in the case of series combination. The bulb with more wattage gives you more power in the case of parallel combination. Okay, that how it will come and all we will discuss that. Now first of all write series combination. Series combinations of bulbs. Series combination of bulbs. Series combination of bulbs. Not only bulbs, it might be the heaters also, anything. See, in series combo, first of all, let me take the rated powers are P1 and then P2. These are the rated powers. Next, in the consumed powers after the series combination is here, I will take it as P1 dash and then P2 dash. Power consumed is directly proportional to the brightness. If more power is consumed, nothing but more brightness will be there. Most confused questions are that only. So you have to understand these combinations properly. One is series, another is parallel. In that main tricks will be there, I will tell you in the note point, but you have to remember that properly and then understand first of all. Now here I have said that the rated powers are what here? P1 and then P2. Let us consider P1 is greater than P2 for the easier understanding. Then power consumed by the first bulb is how much here? P1 dash, and then power consumed by the second bulb is P2 dash. Now if P1 and then P2 are the initial powers, rated powers, at that time what is the resistance relation? Initially how to calculate the resistance, by what formula? R is equals to, what is the formula you have to use? R is equals to V square by P. Then R is equals to V square by P, nothing but R is what I can say? Inversely proportional to P. For whichever there is a more power, for that what will be there? Less resistance will be there. For this, for the P1 is more power, nothing but what I can say? R1 is lesser than R2. You understand till here? I am not doing any combination yet. I am just saying that initial resistances of the bulbs. So for that, I have taken that rated powers are P1, P2 here, and the resistors are R1 and then R2. Now to calculate the resistance and then current, I said always you have to use only one formula, that is V square by P in case of resistor. In case of current, that will be P by V. Okay, that is the formulas you have to always use. Now I want to find resistance of two bulbs. For that, R1 is equals to what I can write? V square by P1, R2 is equals to V square by P2. Nothing but what I can say? R is inversely proportional to the P. This is which power here? Rated power or consumed power? Rated power. So that rated power, this is specified power otherwise. Now this one is, if I am increasing the P value, nothing but at that time what happens? Resistance will decreases. So here P1 is greater than P2, nothing but what I can say? R1 is lesser than R2 because P is inversely proportional to R. That is finished. Now we are connecting in series. Whenever we connect in series and then applied a potential V only here, let us consider. At that time, power consumed by the first bulb and then second bulb will be different. So which bulb will consume more power, that will gives you the more brightness. Clear? So now we will see that P1 dash and then P2 dash. In series combination, what will be same? Current is same. So what is the power formula then in terms of current and then resistance? In terms of current and then resistance, I square into R. So that P is equals to I square into R. Now whenever I want to calculate the power consumed by the first resistance, then what I can say? P1 dash is equals to I square into R1. That divided by second power consumed. P2 dash is equals to what I can say? I square into again R2. In both the bulbs same current only. Why? Because which combination? This is series combination. Now I square gets cancelled here. Then what I can say here? P1 dash by P2 dash is equals to R1 by R2. From this here, can I say that P dash is directly proportional to R? After the combination, can I say that P1 and then R1, P2 and then R2? Can I say that P dash is directly proportional to R? Yes. Now in our problem, given problem, R1 is lesser than R2. R1 is lesser than R2 means what I can write here? If R1 is lesser than R2, then what I can write? P1 dash is lesser than P2 dash. Why both are same here? Directly proportional to each other. Here why both are different here? Initially the resistance is inversely proportional to the rated power. So here P dash is directly proportional to R means if R1 is lesser than R2, at that time I can say that P1 dash is lesser than P2 dash. Now all together if I want to write, first and foremost I have considered that P1 greater than P2. Which power this is? Rated power. So that this is a rated power. And after that we got R1 is lesser than R2. Why we got like that? Rated power is inversely proportional to the resistance. Now P1 dash is lesser than P2 dash. Why we got like this? The consumed power is directly proportional to the resistance. P dash is nothing but consumed power, P is nothing but the rated power. Rated power is inversely proportional to the R, so only P1 greater than P2, then R1 less than R2 we got. Then the consumed power is directly proportional to R. Directly proportional to R means whichever is less, that will have less power consumed. And then whichever is having more resistance, that will have more power consumed. So here P1 dash is lesser than P2 dash. Whenever you see these two relations, what you can say? See that this is about what power I said? Rated power. This is about what? Consumed power. Consumed power. So which is having more rated power, that will have less power consumption. Less power consumption, nothing but what I can say? Less brightness also. Clear? The bulb which is having less wattage, otherwise less specified power, that will have more power consumption. Clear? Now in this case, if I say this is of 100 watts bulb, this is of 40 watts bulb, which will give more brightness? Which one? 40 watts, right? Why? Because the rated power is less and then power consumption will be more. Power consumption is more means automatically which will be more? Brightness is more. So that here brightness is more. Brightness is more, this one brightness is less. Clear? You understand the relation, right? We have not yet discussed the effective power. We are just discussing about the which bulb will glow more. For that purpose, I have taken, listen again properly, I have taken two bulbs of ratings how much, nothing but P1 and then P2. P1, P2 are power ratings, P1 dash and then P2 dash are what? P1 dash and then P2 dash are what? Consumed powers. P1, P2 are power ratings, initially whatever the manufacturer has given. And then P1 dash, P2 dash are now how much power they are consuming, how much brightness they are giving. That is what about the P1 dash and then P2 dash. Now here I said that the resistances R1 and then R2 of the resistances of the bulbs here. Now initially without connecting anything, I want to find out the resistance, means resistance R is equals to, what is the formula for us? V square by P only. So only P is inversely proportional to R. If P1 greater than P2, nothing but what I can say, R1 is lesser than R2. Now you just keep it aside. Now you are connecting in the series combination. For series combination, the power consumption after connecting in the series combination, the power consumption is how much here? P1 dash and then P2 dash in the both the bulbs. Now in series combination, which will be common for us? Current is common. So that current is same, nothing but what is the relation you have to take? P is directly proportional to R. If voltage is same, nothing but what you have to take? P is inversely proportional to R. How to get that? P is equals to I square into R. P is equals to V square by R. Whichever is given in the constant, that should be there in your formula. Clear? So now P1 dash is equals to I square R1, P2 dash is equals to I square R2. I is same because that is a series combination. I square gone. Then P1 dash by P2 dash is equals to R1 by R2. From this what I can say, nothing but the consumed power is directly proportional to R. But rated power is inversely proportional to R. Now if R1 is lesser than R2 means what I can say, power consumption of the first one also lesser than the power consumption of the second one. Now I will write together everything here. P1 greater than P2, hence R1 less than R2, and hence P1 dash is less than P2 dash. Nothing but the first one will consume less power as compared to the second one. Less power consumption means less brightness. So only first one will not give that much of brightness as compared to the second one. Clear, right? Everything you understand? So in series combination, what we can say the conclusion? In series combination, the bulb with less wattage gives you more brightness. Clear? Huh? In parallel it will be reverse. I will show you even that also. Write that. Combinations of bulbs. Combinations of bulbs. P1, P2, P1, P2 are the rated powers. P1, P2 are the rated powers. Comma. P1 dash and P2 dash. P1 dash and P2 dash are consumed powers. Isn't power consumption, brightness, dissipated, radiated, everything is same only. Okay na? But rated is different. Rated is nothing but what? Given power, whatever the manufacturer given. Okay. What I said? P1 dash, P2 dash are consumed powers. To calculate the resistance initially, to calculate the resistance, of two bulbs, R is equals to, what is the formula? R is equals to V square by P. R is equals to V square by P. As R is inversely proportional to P, if P1 greater than P2, then R1 less than R2. Series combination. Now write the series combination. That will be same for series and then parallel combination. First one. Now series combination. As the bulbs connected in series, current is same in both, then the power consumed, P dash is equals to I square into R. Then P dash is directly proportional to R. Comma, as the R1 less than R2, then P1 dash less than P2 dash. And hence everything you write at a time. P1 greater than P2, in the same line you write P1 greater than P2, comma R1 less than R2, comma P1 dash less than P2 dash. P1 less than P2 dash. P1 dash less than P2 dash. So that the bulb with గుడ్ మార్నింగ్ పోయలు వాష్రూమ్ పిలుస్తుంది పో. ವಾಟ್ ಐ ಸೆಡ್? ಒಂದು ಮಾತು ಕೂಡ ಅರ್ಥ ಆಗಿಲ್ಲ. Bulb with less wattage will gives more brightness. The bulb with less wattage gives more brightness. Copy everything. Everything as it is you copy again. ధన్షు బాగున్నావా? కళ్ళు మూసుకొని రాస్తున్నావు. ఎంత టాలెంట్ రా నీకు అసలు. Finished? Yes, next effective power. To calculate the effective power, generally power in terms of resistance, if I keep the same voltage, nothing but 2 bulbs of same voltage I have taken, at that time what is the power formula for us? P is equals to V square by R. Now P effective is equals to what I can write? V square by R effective, of course. Why? Because the V is constant I have taken. First bulb also having 220 volts only, second bulb also having 220 volts only. Then P effective is equals to V square by R effective. Then P effective is equals to V square by which combination I said? Series combination. R effective is how much? R1 plus R2. Yes, R1 plus R2. Now I want to get everything as power only. So what we do? Nothing but I'll just do reciprocal of this entire equation, that is 1 by P effective is equals to what I can write? R1 plus R2 by V square. Then this one what I can write here? R1 by V square plus R2 by V square. What is that R by V square? 1 by P. Why? Because P is equals to what is the formula? V square by R. Then 1 by P is equals to what I can say? R by V square only. So that what I can write here? 1 by P series. 1 by P series equals to what I can write this one as? 1 by P1 plus 1 by P2. That's it. 1 by P1 plus 1 by P2. That is the effective power in the series combination. So clearly what I can write here? P series is equals to P1 P2 by P1 plus P2. Now I have taken the bulbs in parallel combination. We will see which will glow more. Effective power will calculate easy only, but which power will be more, nothing but which will consume more power we will see. For that, first of all we know the relation already. P1 greater than P2, rated power is greater than P2, nothing but what I can say here? Resistance R1 is lesser than R2. Just by the ratings only I said that. Now I have connected in the parallel combination. After connecting in the parallel combination, I got the power consumption as P1 dash and then P2 dash. Now P1 dash is the power consumption in the first bulb and then P2 dash is the power consumption in the second bulb. Now I want to get the relation with the resistance. How to do that? How to get that? What I can say? P is equals to, in parallel combination, right? Parallel combination nothing but which will be same? Voltage is same. So that what I can say? P is equals to V square by R. Now P1 dash is equals to V square by what I can write? R1, that divided by P2 dash is equals to V square by what I can write? R2 dash. Everything is finished now. V square gets cancelled. Here what I can write? P1 dash by P2 dash is equals to R2 dash by R2 by R1. That's it. R2 by R1. Now from this what I can say? Here 1, here 2, here 2, here 1, nothing but what I can say? P dash is inversely proportional to R. So that P dash is inversely proportional to R. Of course we got from here only directly. So P dash is inversely proportional to R means whenever R1 is lesser than R2 gives you what here? P1 dash is greater than P2 dash. Nothing but the bulb with less resistance will give more brightness. Clear? So less resistance nothing but what it is having? Less resistance nothing but more power rating. Clear? Altogether if I want to write, then already we know that P1 greater than P2. From that what I can say again? R1 is lesser than R2. If R1 less than R2, then what I can write? P1 dash is greater than P2 dash. Now what you can say nothing but which is having more rating? that will give more brightness. Which is having less rating, that will gives you the less brightness. Clear? You understand, right? In series combination, what we said? Less wattage, nothing but more brightness. In this, more wattage means more brightness. Clear? Now this is about the parallel combination. Now we will see the effective power. For calculating the effective power, what will get automatically? What is the formula you will get? P effective is equals to what we can get? P1 plus P2. That's it. We will see that. So here I said that P effective is equals to, again what is the formula? Automatically potential is same, V square by R effective. Then P effective is equals to V square into what I can write? 1 by R effective. Which combination this is? Parallel combination. So parallel combination, nothing but what I can write? P effective is equals to V square into 1 by R parallel is equals to what is the formula? 1 by R1 plus 1 by R2. So that 1 by R1 plus 1 by R2. Now P effective is equals to, I will send V square inside, V square by R1 plus V square by R2. Now P parallel is equals to what I can write? This one is what? V square by R, nothing but P. So that P1 plus P2. That's it, finished. This is about the parallel combination, effective power in the parallel combination. Now look at the board again. I have taken two bulbs of different powers. Let me take the power P1 is greater than P2. If the P1 greater than P2, already we know that the resistance formula R is equals to what is the formula? V square by P, then R is inversely proportional to the P. If P1 greater than P2, nothing but what I can say? R1 is lesser than R2. Then we got that relation, and then after that we are connecting in the parallel combination. At that time the power consumed is how much here? P1 dash and then P2 dash. Parallel combination, nothing but automatically what is common here? Potential is common. So the relation between the power and resistance is what? P is equals to V square by R. Now P1 dash is equals to V square by R1, P2 dash is equals to V square by R2. From that we got the relation as P dash is inversely proportional to R. If R1 is less than R2, then what I can say? P1 dash is greater than P2 dash. Now altogether if I want to combine the equations, means I can say that the consumed powers, consumed with the rated powers P1 greater than P2, then R1 less than R2, then hence what we can write? P1 dash is greater than P2 dash. Now this is about the consumption, consumed power, which is having more wattage, that will have more brightness, otherwise that will have more power consumption. Which is having less wattage gives you less brightness. So here P1 greater than P2, nothing but which will glow more? P1 will glow with more brightness as compared to P2. Like this. Clear? They will ask directly straight away questions like that only. They will give two bulbs and then they will say the connection, and then you have to find out which one will glow more as compared to the other one. Clear? Copy everything. ನಿದ್ದೆ ಮಾಡಬೇಡ್ರಿ. Yesterday I said that don't sleep by opening your eyes, means now you are closing and then you are sleeping. ಯಾಕೆಮ್ಮ ಬಿಸಿಲು ಬೇಕಾ ನಿಮಗೆ? ಬಿಸಿಲು ಬೇಕಾ? ಮತ್ತು ಯಾಕೆ ಇದೆಲ್ಲ ಕ್ಲೋಸ್ ಮಾಡಿಬಿಟ್ಟಿದೆ, ಓಪನ್ ಮಾಡಿಬಿಟ್ಟಿದ್ರು ಅಂದರೆ ಕ್ಲೋಸ್ ಮಾಡಬಾರ್ದಾ ನೀವು? Dehydration, you will get dehydrated. Are you drinking water? In this class, whoever are sitting, drink more water. What Yuvaraja? ವಾಶ್ರೂಮ್ಗೆ ಕಳಿಸ್ತೀವಿ, ಪರವಾಗಿಲ್ಲ. ಉದಯ್ ಈಸ್ ಮಾನಸ ಚೋರ ಅಂದರೆ ಏನೋ ಗೊತ್ತಾ? ಮಾನಸ ಚೋರ, ಚೋರ ಮೀನ್ಸ್ ವಾಟ? ರೈಟ್. ಮಾನಸ ಚೋರ ಅಂದರೆ ಮನಸ್ಸನ್ನು ಚೋರಿ ಮಾಡಿ ಅವರವರು ಮಾನಸಿಕ ಚೋರನ. ಮಾನಸಿಕ ಚೋರ. ಫಿನಿಶ್ಡಾ? Yes, in parallel combination, write as a note point. In parallel combination, bulb with more wattage gives more brightness. See, we will write the conclusion terms here. In series combination, you have to tell the relation. In series combination, of course P1 greater than P2 only, and then R1 is less than R2 only. There is no change in that. In series combination, tell me that P1 dash is less than P2 dash. So that P1 dash is less than P2 dash. Now, the power consumed, or what I can say this one as brightness. Power consumed or brightness is directly proportional to what I can say? Directly proportional to nothing right here. Directly proportional to nothing. Is inversely proportional to the power consumed. Rated. Power consumed is inversely proportional to how much? Power rated. And is again inversely proportional to what here? Resistance. See that both are directly proportional. So now look at the board. The power consumed P1 dash and then R1 dash. Here P1 dash less than P2 dash, R1 is less than R2, means what I can say? P dash is directly proportional to what I can say? R, and then it is inversely proportional to P. Why? Because here P1 dash less than P2 dash, here P1 greater than P2. Nothing but both are in opposite, right? Inversely proportional to each other. Now the power consumed P dash, power consumed or brightness, is inversely proportional to the rated. Why? Because here P1 greater than P2, P1 dash is less than P2 dash. Both are inversely proportional to each other. Inverse. Then after that, whenever you see this power consumed and then resistance relation, both are less than only. Correct? So that what I can say? The power consumed is directly proportional to the resistance. Less resistance, nothing but what I can say? Less power consumption. In which combination? That is series combination. And then in parallel combination, whenever you come to the parallel combination, already we know the relations. P1 greater than P2, R1 less than R2, then what I can say? P1 dash is greater than P2 dash. Then the P dash, that is consumed power, what I can say of consumed power is directly proportional to the rated power and also inversely proportional to the resistance. Write these 2 points, very very important. Directly problems will come based on this. Very important. Series combination separately and then parallel combination separately. Maximum power. When the power will be maximum, already we have discussed yesterday itself. Load resistance is equals to the internal resistance. That is how much we got, NR by M we got in the mixed grouping of cells. In the same way, now I have taken the cell of EMF E and the internal resistance R that is connected to a bulb, any load, that might be any load resistance I have taken, bulb, fan, anything that might be. That is how much RL is the resistance of that. Now you have to calculate the when the power will be maximum, at what values of these values then power will be maximum. That is what you have to calculate. For that, I is equals to how much in this? I is equals to what I can say? By applying the loop law, what I can write here? E minus IRL and then minus I into smaller is equals to how much? 0. You understand? First of all, E minus 2 plus nothing but what I can say? Plus E, and then coming into the resistance minus IR and then minus IR. That is equals to how much? 0. Now from this, I is equals to what I can write? E by RL plus R. That is the current. Now I want to calculate the power. Whenever I have the current and then resistance, what is the formula? P is equals to I square into R. So that P is equals to I square into R. Then I is nothing but E by RL plus R whole square into what I can write, which resistance is there here? Load resistance RL is there. Now this P is equals to, we got the answer as E by RL plus R whole square into RL. This is the power I got. I want to make this power as maximum, nothing but my load resistance and then internal resistance should be same. That is what I said yesterday also. So both should be same, nothing but what I can write, if RL is equals to R, then what I can say, then power is maximum. The power is maximum. So if the maximum power is P max is equals to how much we get from here? E square by in the place of smaller I am substituting the RL. Then what will you get here? 4 RL square. Correct? 2 RL whole square nothing but 4 RL square. So that 4 RL square into what is remaining again? RL. RL gone. Then power maximum is equals to E square by 4 RL. This is the formula for the maximum power condition. Whenever they have given only the load resistance and then they are asking to find out the maximum power, nothing but E square by 4 into RL. Instead of RL even, then I can write as what? Instead of RL what I can write? Instead of RL I can write as small r also. So E square by 4R is also one of the answer for that. Clear? Now I have taken a cell of EMF E and the internal resistance R. That might be even voltage also, directly applied voltage also. There is no problem in that. If only voltage given and then load resistance is given means directly you have to substitute this formula, that's it. Clear? Now the cell is given of internal resistance R connected to a load resistance RL. Here load resistance might be bulb, otherwise any other appliance, any heater like that. Now here you have to find out the current. First of all, current is equals to what we will get? E by RL plus R. I got the current and then resistance means what is the power formula? Power is equals to I square into R. So I square into R. I is nothing but E by RL plus R whole square into RL. Now from that, when the power will be maximum, nothing but whenever RL is equals to R, load resistance is exactly equals to the internal resistance, then the power will be maximum. P maximum is equals to E square by, whenever you substitute in the place of smaller RL, then you will get E square by 4 RL. Otherwise they have given only the internal resistance, then what is the formula? E square by 4 into small r. Clear? This is a maximum power condition. Right. Copy that as it is. ಯಾವುದು? P is equals to V square by R ಅಲ್ಲ? ಹಾಂ, ಡಿನಾಮಿನೇಟರ್ ಜಾಸ್ತಿ ಆಗಿದೆ ಅಂದರೆ ಪವರ್ ಮಿನಿಮಮ್ ಆಗುತ್ತೆ. ಅದು ರೆಸಿಸ್ಟೆನ್ಸ್ಗೆ ಪವರ್ಗೆ ರಿಲೇಷನ್ ಇದೆ ಇಲ್ಲ ಇದೆ. ವೆನ್ ದ ಪವರ್ ವಿಲ್ ಬಿ ಮ್ಯಾಕ್ಸಿಮಮ್ ನಥಿಂಗ್ ಬಟ್ ವೆನ್ ಎವರ್ ದ ಇಂಟರ್ನಲ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಇಸ್ ಈಕ್ವಲ್ಸ್ ಟು ದ ಎಕ್ಸ್ಟರ್ನಲ್ ರೆಸಿಸ್ಟೆನ್ಸ್. ಬ್ಯಾಟ್ರಿದಲ್ಲಿ ರೆಸಿಸ್ಟೆನ್ಸ್ ಇರುತ್ತಲ್ಲ, ಆ ರೆಸಿಸ್ಟೆನ್ಸ್ ಇಸ್ ಈಕ್ವಲ್ಸ್ ಟು ದ ಬಲ್ಬ್ ರೆಸಿಸ್ಟೆನ್ಸ್. ಆವಾಗ ಪವರ್ ಈಸ್ ಮ್ಯಾಕ್ಸಿಮಮ್. ಇಟ್ ಈಸ್ ನಾಟ್ ಡಿಪೆಂಡಿಂಗ್ ಆನ್ ದ ರೆಸಿಸ್ಟೆನ್ಸ್. It is depending on the internal resistance of the battery and then external resistance. You are obviously whenever you increase the load resistance, then power only will not be maximum. Why? Because it is not equal to the internal resistance, right? Your question is here, whenever I increase the RL, then what happens? Power will be decreases. Then how can you say that is a maximum? That is what, right, your question? So if I increase the RL, then it will not even equal. If it is not equal, power will not be the maximum. ಅರ್ಥ ಆಯ್ತಾ? Next, fuse. Fuse. What is the row there? Resistivity. Density is not there. Don't think about the density in electricity. Okay na? Density is gone already. So here rho is the resistivity and then L is the length of the fuse wire. Here fuse will be made up of lead and then what is that? Tin. Tin and then lead. Tin alloy and then lead alloy, they will mix together and then they will make a fuse. So that fuse, whenever I raise the temperature, then what happens? Fuse will get break, right? Fuse will blow off. So at what temperature it will blow off, we will find out, and also how much heat is generated by that. Whenever we are just giving the current, by keep on giving the current, for example, if I give the current for 10 minutes, then what happens? It will get heated. If I give the current continuously for 1 hour, then what happens? There will be more heat. So how much power is wasting as the heat energy? That also will calculate H value. And after that, what is the temperature relation? Temperature relation derivation is not necessary, directly I will tell you the formula. Heat will find out normally only. Theta you have to remember. That theta also, you just remember the current and then radius relation, and also theta and then radius relation. Now I will ask you some general question. Whenever I have taken a thin fuse and then I have taken a thick fuse, in which more heat will be generated? Which will break first of all? Thinner one will break first. So that what I can say nothing but, if whenever the radius is less, at that time what happening nothing but, there is a less, what I can say nothing but, it is having more sensitivity to the heat. It is having more sensitiveness to the heat. For example, less radius is there, very thin wire I have taken, it will break soon. What is the reason? Why? Because it is getting less heat also, it is getting breaked. Why? Because it is not able to bear that much of heat. Whenever I have taken a thicker fuse, at that time what happens nothing but, it can stay up to some level of the heat. So here inversely proportional, the temperature is inversely proportional to the radius. We will prove that also. So here fuse is nothing but, it is made up of the tin and then lead alloys. So some percentage of tin they will use and then other percentage of the lead they will use, and then they will mix and then they will make the fuse. Now here fuse of radius, how much I have taken? Radius is R, resistivity is rho, and then length is L. Now first and foremost is I have to find out the resistance. R is equals to, what is the formula? R is equals to rho L by A. Last week exam means last week only you forgot. R is equals to, what is the formula? Rho L by A, right? So that rho L by A. Then R is equals to rho L divided by area, nothing but how much? Pi R square. So that pi R square. This is the what resistance I got. Rho L is rho L divided by pi into R square. That is the resistance we got. Now I want to get the heat. For getting the heat, power is equals to, what is the formula for us? In terms of energy, heat energy I want to calculate. Power is equals to energy by time, right? Power is equals to work done by time or energy by time. So P is equals to energy by time. Then energy is equals to, what I can say? Power into time. Then this energy is which energy here? Heat energy. H is equals to, power is equals to Power is equals to what I can write? Whenever the current is flowing as I. Did I mention any voltage here? No. So what formula you have to use? I square into R. So that I square into R into T. Then H is equals to I square into R value is how much? Rho L by pi R square into T. This is the heat energy produced in that. H is equals to I square rho L by pi R square into T. And also temperature formula is, I will tell you that directly, you have to remember that, I square rho by 2 pi square R cube. This is what the theta, and also into K. How it came? Nothing but this is came by the Newton's law of cooling. Newton's law of cooling is what? Do you remember that? The rate of cooling dq by dt is directly proportional to the theta minus theta. Otherwise, difference of the temperature of the body and then temperature of the surroundings. Do you remember that statement? The rate of cooling dq by dt is directly proportional to the temperature difference of the body and then surroundings. That will get in the thermal properties. So, by this, again what I can write? Nothing but dq by dt is equals to what I can write? Nothing but this is minus k into delta theta we will write. So, this constant only here we got. That derivation is not necessary now. You just remember this theta is equals to I square rho by 2 pi square R cube into K. In this, mainly there is no need to remember this entire formula. Mainly the relation is theta is inversely proportional to R cube. Whenever I increase the radius, then what happens here? Temperature will decreases. Temperature decreases means it is not about the decreasing of temperature. It is about it can bear more temperature. Whenever the resistance is increasing, at that time it can bear more heat. More heat, nothing but the breaking temperature will be less. So here the theta is directly inversely proportional to 1 by R cube. And also I can say I square also directly proportional to R cube. These are the two important relations. More than this formula, you just remember these relations. Theta is inversely proportional to R cube and also I square is directly proportional to R cube. This is about the fuse concept. Fuse nothing but we will take a wire, and then for that wire whenever I increase more radius, at that time what happens means it can bear more heat. And then you might be seen in the household purposes also. Whenever you see, whenever some fuse is going in the home, nothing but at that time what they will take a copper wire. Generally that is only available for our homes. So copper wire will take and then we will just connect the top one and then bottom one. So while connecting that, we will not take thin wire. If thin wire is there, nothing but we will just add 4 to 5 wires and then we will just twist it and then we will add as a fuse. What is the reason? Why we will make more area? Nothing but whenever I am making more area, it can bear more heat. Clear, you understanding or not? Here fuse will be there like this, just beside of the meter, like this it will be there, correct? Inside what happens? Nothing but inside 2 terminals will be there. 2 terminals will be there. For that 2 terminals, one of the terminal will be given by the main supply, and then another is given to the household appliances. Now what happens? Nothing but whenever fuse is gone means we will take the fuse out, and then what we will do? We will connect the wire there and then we will keep as it is. Then what happens? There will be a conduction between the bottom and then top terminals here. So here while connecting that fuse, instead of taking one wire, we will take the number of rounds. What is the reason? Nothing but whenever we take the number of rounds and then we have to twist and then we have to connect in between. So what is the reason? Nothing but whenever I twist more number of wires, I am increasing what here? Area. Whenever I increase area, it can bear more heat. So if there is any fluctuations, nothing but what happens? There will be more heat. That heat it has to bear nothing but it should contain the more area. So only we will twist the wires and then we will put the further fuse. Instead of taking one wire, we will take the number of wires. Same concept only here also. So here what I said, theta is inversely proportional to R cube. If I increase the radius, then what happens? Nothing but it can bear much temperature. Clear? So that is about the fuse concept. Copy that. Fuse made up of what? Tin and then lead alloy. Fuse is made up of tin plus lead alloy. Tin plus lead alloy. Copy everything. What's his staff?